Now I would like to explain about the queue data structure, right? The queue is also a linear data structure like stack, but we are perform operations at the two ends. So we know that this is the stack. The stack is also a linear data structure, right? Here we perform the all the operations, that means either inserting, that means push, or removing, that means we are pop the elements from the stack at only one end. But the queue is like that. So the queue is like that. This is the queue, right? This is the queue. Let us consider this is the zero position, 1, 2, 3, 4, like that. And this is one open end. This is the another open end actually. So the one of the open end where we insert the elements into the queue is known as front, and from which open end we remove the elements from the queue is known as rear actually. So we simply say that the queue is a double ended, that means two side open data structure. We are able to perform same two operations on queue. One is the insert operation. The insert operation on queue is known as NQ. NQ means we are inserting the operations on queue, and also we are able to perform the remove the elements from the queue. To remove the elements from the queue is known as DQ, right? NQ means insertion of the elements into the queue. DQ means removing of the elements from the queue. So generally we insert the elements from the front end of the queue, and we remove the elements from the rear end of the queue. Now let us consider this is the queue. This is the queue, right? It has the capacity of some 3 to 4 elements simply, right? This is the zero position, first, second, third position. Suppose we are add an element from the front, that means NQ. I am going to be add A here. Suppose I am add one more element from to the queue. Now let us consider I draw one more, that is the G, right? 0, 1, 2, 3. Now A is moving one position forward and B is inserting here. In the same way, I would like to add one more element to the queue, right? Now we can observe that A is moving one more position forward, and A is here, B is here, and C is here. So this is 0, 1, 2 position. So we are removing any element from the queue, that means we are perform the DQ operation. So A is removed out. Let us consider A is out. Now in this position B, and in this position C. Suppose let us consider this is the zero position, again 0, 1, 2, 3, like that. So here we can observe that which of the element which is entered first into the queue, that is the first element which is exit from the queue. So the queue follows the FIFO procedure or operations. That is FIFO. FIFO means first in, first out. First in, first out. That means which element first entered into the queue, that is the element first removed from the queue, right? So the queue is a first in, first out linear double ended data structure, right? And we are implementing the queues again in two ways, either using the arrays and implementing the queues and linked list. So we implementing the queues by using the arrays. When we are implementing the queue by using the arrays, the array size is always fixed. That means the number of elements, once we define, we are unable to change the size of the queue. The second one, we are implementing the queues by using the linked lists. We know that the linked list is a non-linear data structure. We can increase the number of nodes or size of the linked list depending upon our requirements. So what are the ADT operations we are able to perform on queue? The first operation is we are creating a queue, right? Create the queue. The second operation is we check the queue is full. The queue is full. And the third operation is empty. We check queue is empty. And fourth operation is actually NQ operation. That means insert. I am going to write NQ. And the fifth operation is DQ operation. DQ means we are removing the elements. So the create operation create the queue, and full operation checks whether the queue is full or not, right? The third operation empty operation checks actually the queue is empty or some elements in the queue. The NQ operation is try to insert the element into the queue. The DQ operation try to remove the elements from the queue. These are the ADT functions or abstract data type operations performed on a linear data structure queue. And one more important is the queues are several types. What are the different types of the queues? So we can classify the queues into the different types. I write here types of queues. So up to now we are discussing one is the simple queue, simple queue. The second one is a priority queue, priority queue. The third one is a circular queue. The fourth one is a double-ended queue, double-ended. So the queues are four types, but here we are discussing about the simple queue. Is it possible? I am discussing about the circular queues also. Okay, friends. Thank you.